Welcome to the third video. I think it's the third. I'm not exactly sure where I'm up to with this, but the next video in this series of examples where I'm looking at adding state behaviors to characters in a game. And where we got up to last time was this kind of field of stars and a single moon where I could trigger different states on each moon depending on where I was. So like that one over there is twinkling, and the one sort of right up on the other side is chasing. And if I get close enough, it should turn into this bliss state, which kind of actually looks like a very ferocious state, but I'm not going to update the graphics at this stage. So in this video, where I want to go next is to change it so that when these stars are chasing, or when they're blissful, they actually move according to what their state is. So when they're chasing, they should actually move towards the moon. And when they're blissful, they should just kind of like zen out, right? And kind of go into this bliss state and ignore the moon. And then when they're twinkling, they should maybe like rock back and forth and happily twinkle away. That's what I'm going to do in this example. So let's zoom out of that screenshot there, and I'm going to go back into my sketch and turn off this debugging stuff, I think, for a moment. Well, I might leave the debugging, the visual debugging in, just so it's easier to see what's happening and talk through it with you. But I'm definitely going to reduce the number of stars. So I'm going to reduce it from 10 back to maybe 2 stars is probably enough. I want to keep more than one just so I can sort of see the dynamics of different stars and how they behave. But yeah, 10 was too many, so I think 2 stars will be good. And what I'm going to do to start with is I'm just going to click into the star.js and just sort of think about what I'm going to do in this update function now that I have these different states. Right, so let's move this over here. And maybe what we should do is actually map that out on, or look at the diagram that I made before for how these will behave differently. Just bring up the overhead camera. Let's think firstly about just the twinkling state. That's probably the easiest one to begin with. I'll do the twinkling and then chasing and then blissful. Twinkling state is just going to be, it's just going to be wobbling back and forth, sort of like twinkle, 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 like that. Let's make that happen. So change back into the sketch, and what I want to do is in update, after I've checked the state, now I know what the new state is, I can say if this dot state equals twinkle, do something else, if this dot state equals chase, I want to do something else. Otherwise, if the state is bliss, I want to do something else. So if the state is twinkling, I want it to kind of rock back and forth. So I think it would be useful for me to actually keep track of like a counter, like frame count, but for each individual star, right? So if I imagine that each star kind of has its own age. So let's say this dot age plus equals 1. So the age of the star is going to kind of increase each time we update it. It's going to get like 1 millisecond older or whatever. And when it first is created, I'm going to say this dot age equals 0. So it starts off at 0 and then it increases as we go. And then I'm going to use the age to actually, I'm going to use the noise function and have it sort of like move a bit randomly depending on its age. So this dot angle equals noise using this dot age divided by 100. So the noise function will give me a number back between 0 and 1. And what I want to do is map that onto an angle. So let's take that number, this dot angle, and map it. So this dot angle equals map this dot angle, which we know is going to go from 0 to 1, and we want to map that onto a range of angles from -10 to 10. And I'm thinking in terms of degrees here. So I also just need to set an initial angle, so this dot angle equals 0. Right, so now that I've got that angle, when I draw the star to the screen, I can use the angle to make it wobble a little bit. So when we're twinkling, when I do this twinkle here, I don't want to just draw the image, I actually want to rotate by that angle depending on my age. So I'm going to say rotate, rotate this dot, and I want to turn it into radians, this dot angle. So you can see the stars are actually moving a little bit there. They're moving a bit left and right. I think they're moving a little bit too slowly, so I can speed up kind of how fast they change with this noise function by changing like how much we divide by here. So if I change that to 10, they'll move 10 times faster. So I think they're moving, that's a nicer speed for them to move at. I think they should probably move a bit further. So rather than -10 to 10, I'm going to map it from -20 to 20. So I think that looks better. Now, one thing that is slightly odd is that both of the stars are kind of rotating at exactly the same angle each time, and that's because they start off with the same age. So when we call the noise function for each one, we're always going to get back the same number. That's how noise works. If you give it the number 5, you'll always get back some random kind of number between 0 and 1. So if I want these stars to each have its own individual kind of little twinkly wiggle, I need to set the age to be different, a random age when they're first created. So here, if I say, rather than just setting the first initial age to be 0, if I say this dot age equals random 1000, so each one gets a slightly different age, they're all going to wiggle in a slightly different different way. So you can see there they're wiggling out of time. They're not, yeah. It's hard to see because I can only kind of look at one of them at a time. It would be easier if they were right next to each other. Let me just do that. In Sketch, when I create them, I'm just going to put them right next to each other. So I'm going to put them at height over 2, both of them at the same height. And I'm going to put them at 100 plus I times 20 or 30. Let's do that. Yeah. Yeah, so you can see they're wiggling in a different kind of rhythm. I think that's nicer. Spread them out a bit. That's good. Okay, so that's the twinkle, right? So they're going to wiggle like that when they're twinkling, so they update their angle each time when they're twinkling. Now let's think about the chase. How should they update themselves when they're trying to chase the star? If I switch back, so I've got in this diagram that when they're chasing, they kind of want to move towards the position of the moon. Right, so let me actually just diagram that out and think about how would we go about making our stars chase the moon in that way. Oh, the screen has gone a little bit of interference here. I think it's probably because the light that I'm using starts to generate some kind of flicker after a while. So I'm going to turn that light off. It might make the image a little bit darker, but it should be okay. All right, so let's think about this. So on my canvas, I have the star and I have the moon. And both of them have an X, Y position. Now, anytime that you want to sort of think about directions and movement, it's often much easier to do that using vectors. And if you remember what a vector is, it's basically just an arrow. It's an arrow that has a length and an angle, right? So if you think about the arrow that points between the center of the star and the center of the circle, that's going to have a certain length and it's going to be pointing in a certain direction. And we'll use both of those things to update the position of our little star. All right, so in the star.js, I'm going to go into update, and then we're going to think about this one. So if the state is chase, figure out the direction to the moon and move toward that. So I'm going to create that as a vector actually. I'm going to say let chase vec equals create vector. And how do I create a vector out of these two xy positions of the star and the moon? Well, basically all you have to do is subtract the x position of the moon, subtract the x position of the star from the x position of the moon, and subtract the y position of the star from the y position of the moon. Because if you think about it, you've got this y position here and this y position here. If I subtract this one from this one, I'll get that y there. And if I subtract this x of the star from this x of the moon, I'll get this x distance here. And that little x and that little y together, they make up the vector. So you can use this for any time that you want to have a vector between 2 points. You just take the y position of the point you want to go to and subtract the y position of the point you're coming from. And same for x. So I go moon.x minus this dot x and moon.y minus this dot y. The other thing we can do with the vector is we can change its length. So I said that the this vector has a certain length from the star to the moon. We can shorten that. We can say set it to something less than that. We can limit it to a maximum amount. And P5.js provides a function for that, which is, we can say chase vec dot limit r1. And I could put anything I like in, but that's going to set its maximum length to 1. Then once I have that little vector, I can say this dot x plus equals chase vec dot x, and this dot y plus equals chase vec dot y. Let's see if that works. So they're twinkling, and it's now chasing, it's moving towards the moon. And you can see as I move the moon in different directions, it chases around it. Then it's in this bliss state. Now this one's moving towards the moon, and it's in its bliss state. Happy, 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 happy. Okay, so that's the chase state. Now let's think about the bliss state. Do we want the look, the way that the star is shown to be different when it's in the bliss state? I think like one thing that we could do is maybe have it kind of just rotate around and kind of like as if its head spinning. You know, it's really up to you what you want it to do, but let's just work with that. And what I'm going to say is, if I go back to my class here, I can reuse this angle, right? So the angle, when I'm twinkling, the angle kind of just changes like this, but when it's blissful, I think the angle should sort of spin around quickly. So what I can basically say is, if the state is bliss, this dot angle plus equals radians. I'm thinking in degrees, so if I just increase it by 5 degrees each time. Make that one blissful. Ah, it's not. If this dot state equals bliss, this dot angle plus equals 5. Ah, because I need to, when I'm showing it, I actually need to change. So in the show function, I was only ever actually rotating when I was in the twinkle state. So it's probably actually worth rotating for all of the states. Even though we're not using it in updating it in chase yet, I think we can in a useful way. So if I move that outside of that if statement, yeah, so it looks like it's kind of getting dizzy. I think I'm quite happy with the way that works. But one other thing we might want to do is make it so that you can see as the stars are changing direction, they're not really changing their angle. And we could make it look more like they're going towards the moon if we change the angle so that they kind of rotate towards the moon as they try to go near it. So let's do that. I will in the update for the chase part, just spin around in a dream. So in the chase part, I can also use the angle of that vector to set the angle of the star. So this dot angle equals chase vec dot heading. So when the heading method gives you the angle in radians, so I actually need to convert this to degrees. Okay, so you can see now the star kind of rotates around towards the moon. I think that looks better. Right, last thing that I sort of think might be a problem for us in this game is that eventually what we're going to end up with is all of the stars are kind of like just in one spot, basically. So I think to avoid that, what would be nice is that when they go into the bliss state, they pick a new random position on the canvas, and then once they come out of the bliss state, they start moving towards that through their twinkle. So they kind of gradually drift across the sky. So let's create a new two new properties of the star, which will be kind of a target x and a target y value. So this dot target x, and that will just start off being whatever x was given, and this dot target y equals y. And what I can do is when we go into the bliss state, in the check state function, when we go into the bliss state, we can also randomly pick a new xy target. So this dot target x equals random width, and this dot target y equals random height. So I pick those targets when I go into the bliss state, and then in the twinkle state, when I update, I can just check, am I at my target yet, right? So if I'm in the twinkle state, I can say let, and I'll sort of do it in a similar way to the way I did this chase vector here. I can say let target vec equals create vector target x minus this dot x and target y minus this dot y, and then target vec dot limit, and I'll make it move really slowly, like 0.2. It's just going to sort of drift to its target, and then this dot x plus equals target vec dot x, and this dot y plus equals target vec dot y. And I'm going to, now that I have this target xy, I'm going to draw that onto the screen in my debug as well. So when I do my show debug, I'm going to draw another circle, stroke. I don't know, should I make this yellow? I'm not sure. I'll just choose some random color and draw a circle at that position. Okay. Line 32, I probably forgot to write the this dot. Yeah, this dot target x. And this dot target y. I'll just put that on a new line so it lines up a bit better. So you can see that that second star is kind of moving back down towards the target at the bottom left of the screen. But as soon as I get as soon as they get into their bliss state, they're going to forget about the old target and go towards a new one. Okay, so I think that is kind of working. I'm quite happy with how those stars are updating based on the different states that they're in. The next part of this series will be me adding the kind of larger game mechanics around collecting bliss, like getting points from these stars being blissful, about trying to make the moon not be too sad or not be too happy. And hopefully that will be the final video in this series. Happy creative coding, and I look forward to seeing what you come up with.